Today we're going to begin looking at the unit circle, or we're going to begin the unit on the unit circle. There are quite a few topics that we need to talk about before we can get to finding values on the unit circle. So things like the degree measures that you'll see, positive or negative angles, how to convert to radians, looking at coterminal or reference angles. That's all part of the unit circle. It's all the parts and pieces you need to fully understand before we can dive right into that topic. So today's kind of an intro lesson about all of that, and we're just learning about angles and their measure in the coordinate plane with respect to the unit circle. So to begin with, we're going to learn how to convert something that's in degrees to radians, which is definitely a new topic for you guys, and then vice versa, so converting radians to degrees. If you're converting from degrees to radians, you need to multiply the number of degrees by pi over 180. And if you're converting from radians to degrees, you need to multiply the number by the opposite, so that would be 180 over pi. And to just see what this looks like when you're actually converting, let's take a look at the examples. For the first example set, we're converting each degree measure to radians, and we're expressing our answer in terms of pi, meaning you should not be using your calculator to write out a final answer. You should be leaving your answer as a fraction with pi. One thing that you should do is you should simplify the fraction. So looking at number one, we have negative 60, and above we are converting from degrees to radians. So in this case, we are multiplying by pi over 180. That means we take negative 60 and we multiply this by pi over 180. This just becomes a fraction being multiplied by another fraction. Recall that 60 is technically over 1. So you can eliminate common factors between the numerator and the denominator. I know right away that 60 and 180 have a common factor, and that would be 60. So 60 goes into itself once, you're left with a negative 1, and 60 goes into 183 times. So then you just multiply across. You multiply your numerators, and then you multiply your denominators. When I multiply the numerator together, I have negative 1 times pi, or just negative pi, divided by 1 times 3, or 3. This is my answer in radians. So that means negative 60 degrees is equivalent to negative pi over 3 radians. All right, looking at number 2, we have 120 degrees. We're going to multiply this by pi over 180. We're going to simplify numerator to denominator. I recognize that 60 goes into both 120 and 180. So I can divide out a common factor of 60, leaving me with 2 in the numerator and 3 in the denominator. Multiply your numerators together, multiply your denominators together. You have 2 pi over 3. And this is your answer. All right, on the flip side, if we're converting from radians to degrees, you multiply by 180 over pi. And a trick to know which one you're multiplying by is if you have the symbol pi and you're trying to convert 2 degrees, you need to eliminate pi. The only way to do that is to make sure that pi is in the denominator. So 180 over pi, that has the value of pi in the denominator, which will allow you to cancel those two values. And that's what you want to do. So again, multiply by 180 over pi. Right away, we can eliminate the value of pi. And then I can either multiply everything together and divide it out, or I can simplify like terms. It doesn't really matter what you do. I think that I'll multiply everything together. So I'll multiply the numerators. What's left is negative 3 times 180, which leaves you with, or I'll just write that, negative 3 times 180, divided by the denominator, which is 8 times pi. Left over is just 8. So in this case, again, you can either simplify that or you could just type this into your calculator. And that's what I'll do. When I type that into my calculator, I end up with negative 67.5, and we just converted that to degrees. So don't forget your degree symbol. Number 2, we have 5 pi over 2. I know it's in radians because I see the pi symbol. So in order to eliminate that, I'm going to multiply it by 180 over pi. Right away, I can cancel those values of pi. And this one, why don't we simplify it before we multiply together, just so you can see the difference between simplifying first versus just typing into your calculator. So here I can eliminate the 2 in the denominator, and 180 will become 90. So now we eliminated both our denominators, leaving a value of 1. All we have left is our numerator, which is 5 times 90, and our solution would be 450 degrees. Now I could have typed 5 times 90 and then in my calculator done divided by 2, and that you would have ended up with the same answer. So here's just a quick note of what we accomplished in this section. You have degrees to radians. If you're going from degrees to radians, you are multiplying by pi over 180. However, if you're going from radians to degrees, you're multiplying by 180 over pi. And you should try the on your own section by yourself, but I'm just going to write in the answers so you can check them. All right, next we're looking at angles in the coordinate plane. So let's talk about some vocab words. These are words that you'll frequently hear me say, so you need to make sure you understand what I'm talking about. The first one is standard position, and standard position is when the vertex is at the origin and one ray is on the positive x-axis. Okay, so if we look at this, here's the origin. Standard position means that you always have one side of your angle on the positive x-axis. By the way, this is what we're working towards graphing. We're graphing angles in the coordinate plane. So again, standard position, origin, one ray, or one side of the angle on the positive x-axis. So going from that side that's on the positive x-axis is called the initial side. It's the ray on the positive x-axis, and it's always on, or I guess I'm repeating myself here, but it's always on the positive x-axis. It never moves. So here's your initial side. It is the side I already highlighted. If your angle is in standard position, that initial side is always there. And the terminal side is the ray that rotates about the center, and it moves all around the coordinate plane. So here is the terminal side in this example. Okay, it could be anywhere, so it's wherever the second side of your angle is. It's called the terminal side. So in this box here, you see positive or negative angles. So it doesn't have anything to do with the value of the angle as much as it has to do with the direction that the angle is moving in. So positive or negative indicates the direction the angle moves in the coordinate plane. And if we review that, if we look at a positive angle, here's your initial side, here's your terminal side, and if I was to draw an arrow, the arrow goes from the initial side counterclockwise to the terminal side. So a counterclockwise rotation indicates that the angle, so this number, is positive. Now this number could be in degrees or radians. Radians is a new topic. We haven't used those before in math. So on the other side, a negative angle is when you still have your initial side on the positive x-axis, because that never changes, but your terminal side located when you move clockwise. So think about the way a clock moves. If you are moving clockwise, that means you are indicating you have a negative angle. And again, that can be in degrees or in radians. So counterclockwise is going to indicate a positive angle, and clockwise indicates a negative angle. So before we move on to the next example set, let's just add a couple key parts to our graphs here. Really quick, if you have a positive angle, you're starting here at the initial side and you're moving this direction. That's a positive angle. With positive angles, you want to notice that you have key points. So you have your 90-degree benchmark, you have your 180-degree benchmark, 270, and 0, which is also 360. And then, of course, this keeps going. So add another 90 degrees or another 180. You can have angles larger than 360. Now, if you have a negative angle, you're starting at your initial side and you're moving clockwise to indicate a negative angle. So a negative angle, while it still has the same benchmarks, because technically we always want to go in the positive direction, there's one thing to note. 270 is the equivalent of negative 90. 180 is the equivalent of negative 180. Positive 90 is the equivalent of negative 270. And 0 is the equivalent of negative 360. Of course, these numbers continue for anything larger than 360. So for the next example set, it says to identify the angle in standard position. So here you're going to want to use your benchmark angles. So use 90, 180, 270, and 360. And the reason why I say that is if we look at number 1, we know that we have our initial side here. We know that we have the terminal side here. We also know that this indicates 180 degrees, but looks like my angle is 45 degrees short of 180 degrees. So I'm going to do 180 minus 45, which gives me the solution of 135 degrees. And that is my answer. Now, if the direction said to identify the angle in radians, you would then take 135 and you would convert it to radians by multiplying by pi over 180. Number two. Number two is already in radians. So there's a few things to note on this problem. First, here's our initial side. Here's our terminal side. You can see that this graph moves clockwise. That means it's going to be a negative angle. But also, our angle is given to us in radians. That means your final answer needs to be in radians. You need to keep your answer consistent throughout the problem. So if it's given in radians, then your answer needs to be in radians. Okay, so I've found in the past that a lot of students like to convert this to degrees in order to solve the problem, and then they convert back to radians for their final answer. You don't have to do that. You could make a note to yourself what the benchmark angles are, and you could complete this entire problem in radians without having to convert between the two. However, I don't find many students do that, so I'm going to teach this by converting to degrees, solving the problem, and then converting back. So I know that this angle right here is pi over 9. If I multiply pi over 9 by 180 over pi, I can eliminate my values of pi, and 180 divided by 9 is 20 degrees. All right, so that's telling me that this angle is 20 degrees. I also know that this is negative 270 right here. So my angle, my terminal side, is 20 degrees short of 270. So I'm just going to do that in my head. 270 minus 20 is 250. So that is telling me that this angle is 250 degrees. I need to add a negative sign to indicate the direction. The direction moves clockwise. So negative 250 in degrees. But I'm not done because my final answer needs to be in radians. So now I'm going to multiply this by pi over 180. Multiplying this by pi over 180, the only common factor I have is 10. 10 goes into 25, 250, 25 times. 10 goes into 180, 18 times. So my solution in radians is negative 25 pi over 18. That's my final answer. And above it, I'm just going to list that it was negative 250 degrees. Okay, so what we did up here was we converted pi over 9 to degrees, and it's 20 degrees. Then we noticed that we have our benchmark angle of 270, negative 270 for the direction. Because we are pi over 9 or 20 degrees short of the 270 benchmark, I subtracted 20 from 270. That gives me my solution of 250. My answer is negative 250 because of the direction the angle moves in. I then took negative 250 and I converted back to radians to give me my final answer of negative 25 pi over 18. Okay, the next example set is sketching angles in the coordinate plane. So we're sketching these angles in standard position, and just recall that you need to pay attention to the direction of the angle. No matter what, every angle starts by having an initial side at or on the positive x-axis. Use your benchmark angles just like we did when we were identifying the angle. So I'm going to think to myself, I have 90, 270, 90, 180, 270, and 360. So in my head, I know that 320 is 40 degrees away from 360. So that means I'm going to make almost a full rotation minus 40 degrees. So I'm going all the way around in the negative direction, and it's just a sketch, so come about 40 degrees away from 360, and indicate that this is your angle of negative 320. It's also a good idea to mark your reference angle, so I'm just going to mark that at 40 degrees. Marking the reference angle just indicates that you know exactly what you're doing and exactly where your angle lies. So what I just highlighted is my final answer. And make sure you always label it. It's a good idea to make sure your answer is complete. Number 2 is 5 pi over 4. 5 pi over 4 is in radians, so we're going to do what we did in the previous, or 2 problems ago. We're going to multiply this by 180 over pi, and we're going to eliminate our value of pi. 5 times 180 divided by 4 simplifies to 225 degrees. So this is what I need to graph. I recognize that 225 degrees is greater than 180, but less than 270 for those benchmark angles. So 270 minus 225 leaves me with a reference angle of 45 degrees. That means I'm coming 45 degrees shy of 270, and I'm moving in the positive direction. When I indicate my final answer, I'm going to indicate that it's 5 pi over 4. I started in radians, so I should be ending in radians. What I'm highlighting in yellow is my final answer. All right, the terminal side of an angle can make more than one complete rotation. For example, a complete rotation of 360 plus a rotation of 120 forms an angle that measures 360 plus 120, which is 480 degrees. So we can graph those. It just means you're indicating that you rotate around the coordinate plane more than once. Number 1 is positive 16 over 3. Let's start by multiplying that by 180 over pi. We're going to eliminate the value of pi. I notice that 3 goes into itself once and goes into 180 60 times. I also realize that 16 times 60 is 960. So we need to graph this. So what I like to do is I like to indicate how many full rotations it is. So I'm just going to make a note. 960 is the equivalent of 360 plus 360 again, plus a remaining 240. So here we have 2 full rotations. Two full rotations, and then we graph our final answer in the same location as 240. So what do I mean by this? It means I graph my initial side, I rotate around the coordinate plane one full time, then one full time, then again for a second time, and then I rotate past that 240 degrees. 240 degrees is just shy of 270. In fact, it's shy by a value of 30 degrees. So that is what an angle looks like that is larger than 360. And when I indicate what it is, I indicate in terms of radians. Okay, so make sure you indicate the number of rotations. So 1 rotation, 2 rotations, a remaining 240 degrees. And that's all found right here. Number 2 is negative 390. We don't need to convert that to anything, but I do know that negative 390 is the same thing as negative 360 plus negative 30. So we have 1 full rotation, and then I graph the angle in the same location as -30. Here's my initial side. I move in the negative direction, so 1 full rotation, and then just 30 degrees past that. All right, next we're looking at coterminal angles. So coterminal angles are two angles that have the same initial and terminal sides, but different angle measures. The first example is an example of a positive and negative coterminal angle. So here we see angle A and we see angle B. For example, angle A could be 150 degrees, that's a positive number, and the opposite angle, or the negative angle, could be negative 210 degrees. Both of these angles, both 150 and 210, have the same initial and terminal side. So the way to find that algebraically, if you want to, is to subtract 360 from 150. Next, we have an example of just two positive coterminal angles. So we have angle A and we have angle B. Let's say that angle A is 150 degrees. And if angle B has the same initial and terminal side, it's the same thing as adding 360 to that. So adding 360 would give you a value of B for 510 degrees. And in order to find that, we would have done 150 plus 360, and that's equal to 510. Either way, whether it's 150 or 510, you're graphing the angles with the same initial and terminal side. If we compare my two examples here, you can see that the first one, the positive and negative coterminal angle, I subtracted 360. And for the two positive coterminal angles, I added 360. So that's the pattern that you can find. One rotation, one full rotation is 360, or 2 pi if you're looking at it in radians. So to find coterminal angles, add or subtract a full rotation, meaning add or subtract 360 in degrees, or 2 pi if it's in radians. All right, coterminal angles. Number one is 60, and we're asked to find an angle with a positive measure and a negative measure that are both coterminal. So that means I'm going to start with 60, and all you're doing here is adding or subtracting 360. So I'm going to start by adding 360, and this is equal to 420 degrees. That's one of your solutions. So here I added. Next, we're going to take 60 degrees and we're going to subtract 360, and that's going to give us a solution of negative 300 degrees. That's your negative answer, and we just found that by subtracting 360. All right, if you want to, you can graph them and you can indicate that they are both using the same initial and terminal side. So here's your two coterminal angles, one positive, one negative. To find this, we add or subtract 360. For number 2, this is in radians, so you could convert to degrees if you want to, or you could know that you're adding or subtracting 2 pi. And that's what I'm going to do. I think it's actually going to save me a little bit of time right here. So I'm going to start by negative pi over 3, and I want to find a positive coterminal angle, so I'm going to add 2 pi. Adding 2 pi is the same thing as adding, let me write this again. So negative pi over 3. Instead of adding 2 pi, we're going to convert to a common denominator, which is 3. So if you have 2 over 1, multiply the top and bottom by 3, you have 6 pi over 3. Now you add these together, you add only your numerators. So negative pi plus 6 pi is 5 pi over 3. There's your positive coterminal angle. And we found that by adding 2 pi. Our negative coterminal angle is going to be found by subtracting 2 pi. If we have negative pi over 3 and we're subtracting 2 pi, it's the same thing as subtracting 6 pi over 3. Negative pi minus 6 pi is negative 7 pi, and our denominator is 3. Here's your negative coterminal angle, found by subtracting negative 2 pi. These don't stop here. There's infinitely many coterminal angles, so you can keep adding or keep subtracting coterminal angles. And the last part of today's notes are reference angles. So reference angles are acute angles formed by the terminal side and the closest x-axis. Acute angles are angles that are less than 90 degrees. All right, here you just see some examples of where your reference angles are in each quadrant. So if you have an angle anywhere in quadrant 1, your reference angle will return back to the positive x-axis. If you have an angle that's terminal side lands anywhere in quadrant 2, your reference angle will always return back to the negative x-axis. An angle with the terminal side in quadrant 3, the reference angle always goes back to the negative x-axis. And an angle with the terminal side in the 4th quadrant, that reference angle always returns back to the positive x-axis. And another note is that reference angles are always positive values. Okay, number 1, finding the reference angle. So we need to first sketch 310 degrees. I know that 310 degrees is a positive angle, so I'm moving counterclockwise. I also know that 310 is 50 degrees shy of 360. So my angle is in this location. So if you're in the 4th quadrant, the reference angle always returns back to the positive x-axis. And if we are, I wrote this wrong, sorry. If we're graphing 310, that means that our reference angle is 50 degrees shy of 360, and 50 degrees is your reference angle. Okay, returns to the closest x-axis, and reference angles are always less than 90 degrees and always positive. Number 2 is negative 2 pi over 3. So we're going to quickly convert this to degrees by multiplying by 180 over pi. and you're left with a negative 120 as the angle that we need to graph. So negative 120 is 60 degrees shy of 180. So our reference angle is going to be this angle that returns back to the positive x-axis, which I know for the time being is 60 degrees, but I need to convert 60 degrees back to radians for my final answer. When I do that, my solution is pi over 3, and that there is my final answer. So pi over 3 and 60 degrees are the same thing, but when your answer or when your problem starts in radians, you need to make sure your answer is also in radians. So your reference angle is positive pi over 3. Again, always less than 90 degrees, always positive. And that's it for today's notes. Let me know if anyone has any questions.